Okay, so we're going to have a look at writing what we call half equations. This is kind of the last topic of GCSE, writing equations. Now, this is covered if you want to have a look at some of the problems that I'm going to do on this. It's covered in your textbook on page 295, and the questions that we want to have a go at on 295 are question 135 and 136. So far we've looked at all the types of, we've looked at writing word equations, we've turned those into writing formulas of reactants and products in word equations. We've then taken that and we've turned it into writing symbol equations. We've then taken that, turned it writing into balanced symbol equations. Then we've been able to put state symbols into our balanced symbol equations, and then finally we've been able to write some of the ionic equations. This is going to be what we call half equations, and half equations are used whenever we have, if you like, half the story, and we're going to balance them up using electrons because the charges in this instance are unbalanced. So I'll take an example, and probably when I do the example that'll make things a little bit clearer. So if we take an example of, let's say, zinc metal, okay, plus copper sulfate, which is a solution, okay, and that goes to zinc sulfate, which is a solution, and copper solid metal. Now, if we take a look at this and we split it into the ionic equation, so I'm already assuming that you've got skills that we've already covered in class. You've got the ability to write the balanced symbol equation, which I've done on the board, put state symbols on it, which I've done, and to turn it into the ionic equation. So the ionic equation for this would be zinc solid plus copper 2 plus ions. The sulfate ion is a spectator ion, so it doesn't come into the ionic equation. It goes to zinc 2 plus aqueous plus copper solid. Okay, now we're looking at the half equation. This is the full equation. The half equation is what happens to each thing in it. So the zinc and the zinc, the copper and the copper. So let's put out the zinc solid, and that goes to zinc 2 plus aqueous, and let's put out the copper. Okay, copper goes from copper 2 plus to copper solid. Now, the only thing we're allowed to use in half equations to balance, because the only thing that isn't balanced, if you look at it, is the charge. Everything else is balanced. Both of those equations have one zinc on each side or one copper on each side. So the only thing that isn't balanced is the charge. So let's just look quickly at the overall charge on each side, because we need to be able to work out. Well, on this side of the zinc equation it's 0, and on this side it's 2 plus, and that's because when things react, we know this from earlier in the topic, earlier in the last topic, the bonding topic, that when things react, okay, they lose or they gain electrons only, and we can only balance these things out by using electrons. So electrons, each electron has a -1 charge, so if I put my 2 electrons on that side, that means on this side I have 2 plus and 2 minus, so it is now 0 charged, the same as that side. So there you go. We balanced that half equation by putting our 2 electrons on the right hand side. Let's look at the bottom equation, the copper equation. On the left hand side of the copper equation, there's an overall charge of +2, and on the right hand side there's of course a 0 charge. There's no charge on atoms, there's no charge on molecules. Okay, so that's actually very worth bearing in mind for what we do later. No charge on atoms, no charge on molecules, only charges on ions. Right, so how do I get my 2 plus and my 0 on the right hand side balanced? Well, this time I've got to have 2 electrons again, 2 negative charges, but they've got to go on the left hand side. And therefore my 2 plus on the left hand side and my 2 minus on the left hand side mean that I have got my charges balanced, and I have 0 overall. Okay, so let's have a look. I'll have a look at one more, and then we'll see. We'll take a couple from the book and we'll have a go at those. Right, let's look at, let's go magnesium bromide solution plus chlorine solution, and that goes to magnesium chloride solution plus bromine. Okay, again I'm assuming that you can balance the equation. That's already balanced, and you can put state symbols in it, and you can pull out the ionic equation. This time the spectator ion is a magnesium ion. So in the first one I have 2 bromide ions, which are not spectator ions. Remember, it's Br2 here means I have 2 individual bromide ions. Chlorine is a covalent molecule, and it just comes down and is popped into the equation as per the rules when writing ionic equations. Here I now have 2 individual chloride ions, not Cl2s together anymore. And I have bromine Br2, which is aqueous. Right, my half equations then. I want to tell the story that what happens to the bromides. Okay, they go to bromine, we know that. Okay, let's balance, let's look at the charges. On the left hand side I have 2 1 minuses, so I have a total of 2 negative, and here I have 0. How do I balance those out? I have to put 2 electrons on the right hand side this time, and that shifts the charge from 0 now to -2 on both sides. Let's look here at then the other one, of course, is the chlorine, aqueous, goes to 2 chloride ions. And if we look at the charges, 0 on the left, -2 on the right, well, the only way I can get -2 is plus 2e minus. So the overall charge on this side is now -2, and the charges now balance up. So I'll look at a couple from the textbook here. I'll go to that question 1, 3, 5, and I'll just do 2. They're really pretty simple ones. If I go to E, and E says O2 minus goes to, the reason I picked this is slightly different from one that I had done. Right? So the first thing that we always do in any equation is we balance the atoms, and if you look on the left, or sorry, the right, I have 2 oxygens, and on the left I only have 1 oxide ion. I can't put a 2 there, that's not the formula of an oxide ion, so I can't do that. Oxide ions like chloride ions, bromide ions, etc. exist individually on their own, so the 2 has to go there. Alright, now everything's balanced up, okay, except the charges. Let's look at the charges. I have 2 minuses, so I have a -4 on the left, and I have no charge on the right, so I've got to have 4e minus there, and that gives me now -4 left and -4 on the right both. Okay, that's fairly straightforward. Let's look then at F, the same question, which is H plus, goes to H2. Now you might want to pause the video there and have a go at that yourself and then come back. So if you want to pause the video, do it now and then come back. Okay, so the first thing we do the same again, we balance up our hydrogens. Now we look at our charges. On this side it's +2, on this side it's 0. So I need the charges to balance out. The only way I can do it is with electrons, so I need to put 2 negative charges or 2 electrons, and that's it. And that brings the +2 down to 0. And now my charges on both sides are indeed balanced out. Nice and simple. Okay, and the last one I'll do is page 135. I'll do I. It's pretty simple, I think. Again, when I read it out here, you can have a pause the video and have a go at it yourself if you wanted to do that. Okay, so pause the video there now if you want. So 0 on that side, 2 plus on that side. I need to add 2 electrons to that side, and there you go. It's balanced at 0 on both sides. Right, let's move down to question 136, which has got words in it now. That last question was dead easy, yeah. So if we look at, let's look at A, where it says we have iodide ions going to iodine molecules. Now, if you remember what I said earlier, I said that molecules and atoms have no charge. Only ions have charge. So that's really important. And it's also important we know the formula of our molecules and our atoms, etc. So iodide ions, we should know -1. They're in group 7. And they go to iodine molecules. Now, iodine molecules are one of the molecules you have to learn. They're the diatomics. So we apply exactly the same principle again. We balance everything but the charges, so I need a 2 there. I now can see that the left hand side is -2 and the right hand side is 0. How do I get both sides the same? I need 2e minus. Both sides are now -2, and that's done. Okay, let's go down and let's look at B. Okay, the same one. B tells me that I have aluminium. And we start off with aluminium ion, and it goes to aluminium, I'll just write alum, okay, aluminium atoms this time, okay? So remember I said earlier, molecules and atoms, zero charge, no charge. Okay, so an aluminium ion is in group 3, so it is 3 plus. We should know that from our ionic bonding, and that goes to aluminium, pure aluminium, no charge. We've got plus 3 on this side, we've got 0 on this side. I need to balance them up. I need 3 negative charges, 3 electrons. There you go. Hopefully we're starting to get this now. So let's look at C, because C is a little bit tricky. C tells me I have a nitrite ion, and that's going to nitrogen molecules. Nitrogen molecules. Sorry about the handwriting on this board. Okay, so nitrite ions are nitrogen. Okay, they're on group 5, so they are 3 negatives. Nitrogen molecules are one of the molecules you have to know that are diatomic. First thing we always do is we balance up our nitrogens, then we look at our charges. So we've got 2 times minus 3 is minus 6 on that side, I've got 0 on this side. So therefore on this side I need 6 negative charges to bring that overall charge to minus 6 on each side, and that's the final answer for on 36, that's part C. Okay, so we'll do just one more. Okay, we'll go right down to the end here and we'll do G. Okay, and G tells me that I have chloride ions. Okay, in fact no, we'll not do G, we'll do F, and F tells me I have a copper 2 ion, and that's going to again copper atoms. So remember, atoms have no charge. So copper 2, the Roman numeral tells me the charge, 2 plus goes to Cu, 2 plus on the left, 0 on the right. I need 2E minus. I'll do G just to finish off. G was my chloride ion, which was going to chlorine, and it tells me it's going to chlorine molecules, yeah? So chloride ions we should recognise as being group 7 and minus 1. Chlorine molecules are one of the diatomic molecules we had to learn in this topic. Cl2, remember to balance everything but charges first, so I need 2 chlorides there, sorry. That gives me a total of minus 2 left. I've got 0 on the right, so I need to bring it down to minus 2 by adding 2 electrons. And that's the answer to that. Hopefully that helps, guys, and you can see what we do with regard to your half equations. And any questions, let me know.